Hello and welcome to this Python tutorial. So let's move on with our grid search implementation. And so now that we built this parameters list of dictionaries that basically contains the different options that will be investigated by grid search to eventually find the best option, the best set of parameters, well, now the only thing that we have to do left is use this grid search CV function to find these optimal parameters. So let's do it. We're going to do that right after this parameters list. All right. And so now what we're going to do is create an object of the grid search CV class, and then we're going to fit this object on our training set. So let's do it. We're going to call this object grid search, then equals, and then since this object is an object of the grid search CV class, now what we need to do is take the grid search CV class, so that's the class, and now we need to input some parameters. So the first parameter is our estimator, and it is called estimator, like this. And so basically this is our machine learning model, whether it is a regression model or a classification model or any other kind of model. And here, since our model is basically called classifier, then this estimator parameter here is estimator equals classifier. All right, the next parameter is param underscore grid, and that's basically this parameters list of the different options that contains this linear option with the linear kernel and the different options of the penalty parameter C, and also the nonlinear option with the nonlinear kernel RBF, and the different options for the penalty parameter C, and also the different options for the gamma parameter, which is the coefficient of the kernel function. So here basically we need to input param grid equals parameters. All right, second parameter done, and now third parameter. The third parameter is the scoring metric you want to use to decide what those best parameters are. Because, grid search is going to select the best parameters based on one performance metric. And it can be the accuracy, it can be the precision, it can be the recall, it can be different performance metrics. And since we can have one model that has a higher accuracy than another model, but then if we take another performance metric, it can have a lower one, well, therefore we need to specify a scoring metric. And we're going to take the most common one, like we did for deep learning. We had to choose a performance metric as well, and we chose the accuracy. That's the common practice, and that's what we're going to do here. So let's do it. Scoring equals, and in quotes, accuracy. Perfect. That's the third parameter. Now, fourth parameter is CV. So CV, as you might have guessed, is the K in K-fold cross-validation. That means that, of course, a grid search is going to evaluate the performance of each of the model with their own set of parameters. And of course, when evaluating the accuracy of these models, it's going to do it through K-fold cross-validation. Because as we saw in the previous tutorial, the first tutorial of this section, well, K-fold cross-validation is the relevant way to evaluate your model performance. So of course, it's not going to measure the accuracy based on one train test split, that is, taking the accuracy of one test set. It's going to take several accuracies, more precisely 10 accuracies, because we are going to input CV equals 10, and then it will take the mean, and therefore it will get a much more relevant performance measure. So CV equals 10, and therefore 10-fold cross-validation will be applied through grid search. All right, and that's actually all for grid search. If you are working on a very large data set, what you can do is add this last parameter that we also saw in K-fold cross-validation, which is, remember, n jobs. And if you're working on a very large data set, then grid search will take quite some time to execute because it's testing some different options, that is basically building different models for your problem that involves a large data set. and therefore it should get all the power available from your machines. So I'm just adding this njobs parameter here and set it to -1 in case you use this code on a large data set. Alright, so that's it for the grid search function. Our grid search object is ready, and now we can use it to fit it to our training set. So what do? We take our grid search object, we can copy it, then equals, and then take it again, then dot, and then that's where we apply the fit method, as usual, to fit an object to a training set or to any kind of data set, and then in parentheses we input the training set. So the training set is composed of xtrain and ytrain, so here we need to input xtrain and ytrain. And here we go. The grid search object will now be fitted to the training set. Perfect. So we can already try to execute this. That is, first let's import the grid search CV class. So let's do it. Here we go. Grid search CV class imported. And now let's define the sets of parameters that are going to be investigated by grid search. So executing this again. Great. And now let's use the grid search function with the selected parameters, and let's execute this. Here we go. Grid search function ready. And now we are ready to fit our grid search object to the training set. So let's do it. Executing this as well. As you can see, it's taking like 1 or 2 seconds, but our data set is small, so it might take a longer time if you have a large data set, but make sure that you enter this njobs parameter and set it equal to -1. Great, so basically grid search is implemented now. And so now what we are mostly interested in is look at the results. And so to do this, it's very easy. We need to take our grid search object and use some attributes to get this chosen selection of the optimal parameters and also the best accuracy score found with this selection. So let's first actually get this best accuracy score. So to get this best accuracy, well, let's define a new variable here that we call best accuracy, then equals. And now, as I just said, we take our grid search object, then dot, and then we use the best score attribute. And we need to add in the end an underscore, like this. So this will give us the best score. We can check it out. I'm going to select this line and execute. All right, best accuracy, it is 90%. So that's very good. And it's not the accuracy measured on only one test set. It's the mean of 10 accuracies measured through k-fold cross-validation, 10-fold cross-validation, and we get 90% accuracy, which is really good. And that's with the best selections of these parameters here. That is, well, we know it took an RBF kernel. We will have the confirmation right away. But then it took also the optimal C, penalty parameter C, and the optimal gamma. So let's see what these parameters are. To get these parameters, well, let's define a new variable best parameters, and then equals, and then again we take our grid search object, then dot, and then we take the best params attribute that will give us this list of the optimal parameters found by grid search. So here we add best underscore params and underscore again. All right, perfect, ready. We are about to know the best parameters for our problem, and not only we'll know if we should use a nonlinear model or a linear model, but we already know that it will be a nonlinear model, that is a kernel SVM. But then what we're mostly interested in and what we couldn't know before, that is in part 3 when we implemented kernel SVM, is the optimal value for C and the optimal value for the gamma parameter. So let's find out about that. I'm going to execute this. Here we go. And what are the best parameters? These are 1 for the C parameter. We were lucky because that's actually the default value. Same for the gamma parameter, that's also 0.5. So we were lucky as well. And of course, it's an RBF kernel, which means that the most appropriate model for our problem is a nonlinear model. So that's good. So we already know the results of this model. We're not going to visualize that again. But then if you want to push further your work on improving the model performance, then what you can do is try some more accurate values for your gamma parameter, because now we know that the optimal value for gamma is around 0.5. So we actually don't need this 0.01, 0.001, and 0.0001. So we can be more accurate here and choose, for example, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, and 0.9. And then, you know, we simply need to select that again, all this section about grid search, and that will do some new search of the new options of parameters. And so if we execute this again, we have a new best accuracy and a new optimal selection of parameters. And so let's see what these are. The best accuracy is now 90%, that's the same. And what are the best parameters? Well, you can see that 0.7 is an even better value than 0.5. So that's if you want to push your work on improving the model performance further. Well, you will get an optimal value of 0.7 for the gamma parameter. Alright, so let's press OK. And now you know how to improve your model performance thanks to parameter tuning. So that's it for this section. I hope it answered to your remaining questions. And of course, if you still have some questions, you can ask them in the Q&A. And now we are almost getting to the end of this course, because the next section will be the bonus section about XGBoost, one of the most powerful models in machine learning, and I look forward to implementing that last model with you in the next section. Until then,